In this video, we'll show you how to set up data sampling to collect time series data from a PLC or other device in EBPro, as well as how to create visual representations of this data to add to your HMI screens, these being real-time trend displays and history data displays. Finally, we'll show you how to back up the data the HMI collects using backup objects. To begin looking at our system parameter settings in EBPro, we don't have any other devices in this project, so we'll just be using simulated data that is written to local word memory in the HMI itself. So to create a data sampling object, first go to the Data History tab and click on Data Sampling. Then click on New to create a new data sampling object. In the comment field, you can name it, but we'll show you the example that is set up in this project, Data Sampling and Trending. Here we've named this Data, and we need to choose whether we want the data sampling to be time-based or trigger-based. If it's trigger-based, then we'll take a snapshot of the data at a specific time, for instance when the trigger address has been switched. But with time-based, we'll just set the interval for sampling. So 0.2 seconds. Every 0.2 seconds we'll be reading from the read address here and grabbing a set of consecutive registers starting at that address. For the read address, in our case, we're using local word 0. And what exactly we are reading is defined in the data records section here. Click on Data Format. And you can see we have added 5 different data records. So these are all 32-bit float data, and we've named them channels 1 through 5. If you wanted to create a new channel representing a different value or variable, you can do this by clicking on New and then giving it a name. For instance, channel 6, we could add and then set it to 32-bit float as well, or some other data type if we wish. Click OK to add that. Now we would have 6 data points we'd be reading in every 0.2 seconds in this case. Now we'll delete this one because in this example we just need 5 channels, but that's how you would set up your data records in the data format section. Now we recommend to save your history to HMI memory, so saving the data that is sampled to HMI memory. You can also save it to USB or SD card, and you can customize how the files are saved and how they're named here. In our case, we'll set a preservation limit of 7 days, so 7 days worth of data will be retained in HMI memory. Click OK when you're done, and then click Exit. Now we're looking at 5 channels of data starting at local word 0. We've set up a numeric object for each of these channels on the common window, so it will always show on any other window. And in order to actually create some simulated data, we're using set word objects. For example, the first channel at local word 0 is using the style of periodic bounce, so values will fluctuate between the low and the high limit, incrementing or decrementing by 0.5 every 0.2 seconds. We've set up the same type of set word object for each of our 5 channels here on the common window. So the second channel at local word 2 uses the same style, as do the other channels at local word 4, 6, and 8. To create the effect of multiple lines that you can see separately on the chart, we also set a starting value for each of these channels using set word objects on the common window. So for channel 1 at local word 0, we use a set value of 10. So when the window opens, when the project starts, it will begin at 10. For the 5th channel, we start at 30, and so on. Let's take a look at the main trend, so you can start to see how this data sampling and the simulated data feeds into the trend display. To start, when you're creating a trend display object, go to Data History and click Trend Display here. We'll take a look at how ours is set up in this project. To begin, from the General tab, select the data sampling object that you wish to use as the source of your trend display. Next, choose whether you want data to be updated in real time or use history mode to allow for viewing more of the previously gathered data from within the trend display. The next step is optional. For the x-axis time range, you can choose either time mode or pixel mode. With time mode, you're choosing the total width of the chart in terms of number of seconds. And with pixel mode, you're spacing out each data point that's drawn on the chart by a number of pixels. You can choose to make this dynamic x-axis time range. In our case, we've set local word 50, so we can modify this, but we start out with the default of 120 seconds for the full span of the x-axis. Next, hold Control. This is optional. You can enable this if you wish to be able to pause the trend display itself. Data sampling will still continue in the background, but you can freeze the chart at a certain moment in time if you wish. We're using local bit 99 as an address to control this. Next, watch line. This we're not using in this trend display, but we'll show you an example later. This allows an operator to click or tap on the trend display itself and then read the values at that specific moment in time. From the Trend tab, we've enabled a grid with an interval on the x-axis of 20 seconds and divisions on the y-axis, 10 total, in order to allow for a visual sense of scale. And you can look at the time scale and time and date options here for formatting if you wish. Next, on the Channel tab, from here we can see that we have all 5 of the channels that we've set up. These are named just as we set them up in the data sampling object itself. And for each of these, if you want it to be displayed, you must check the box in the display column next to it, and then configure things like the pen color and width, and any min and max values or limits for those channels. For ours, we have channel 1 is blue, and channel 2 is red, and we have set a different color for each of the other channels so we can distinguish them easily on the chart. All of these are using the same dynamic limits address at local 100 so that we can set a minimum and maximum value as for what can be shown on the chart. Channel visibility control you can enable if you want to, and this allows you to hide or show each of those channels one at a time. We're using local word 200 in this case, and we'll address the bits of this local word. So if the bit is off, then we will display the channel. For example, channel 1 will look at local word bit 200, and that will start as off. So by default, channel 1 will be drawn on the chart. If we want to hide channel 1, then we would toggle local word bit 200, Turning that on hides the channel. From the Y-Scale tab, you can designate a channel as a main axis and set others to auxiliary. If you do this, then you can display a Y-scale to the left of the chart. The main axis is displayed right next to the trend chart, and the auxiliary axes are displayed further out in the order in which they are sampled, respectively. Here you can dynamically show or hide the Y-scale information for each channel by addressing the bits of the local word address that you set here. For example, we use local word 500 for this, and we'll only show the Y-scale if the corresponding bit is on. To show channel 1, we would turn on local word bit 500, say using a toggle switch. You can also move the auxiliary axes into the main position on the fly if you use dynamic main axis. Here we use local word 30 for this. So we can set on local word bit 3001 if we want to move channel 2 into the main axis position. So just to recap, we have set up a real-time trend display. Having configured it in this way allows us to toggle channel visibility, pan and zoom, pause the chart, and select main and auxiliary axes to show or hide. In order to control each of these elements, we set up some objects on the common window. The idea here is to feed starting values for different trend display parameters into the designated registers. So in addition to the setWord objects, to create our simulated data, we have a setBit object looking at local word bit 3000, and this will make channel 1 the main axis by default when the project starts up. We have a setWord object at local word 50 to set the x-axis time range to 120 seconds. And we have setWord objects at local word 100 and local word 102 to set the min and max for each channel to 0 and 100 respectively. All of these objects are set up to write the configuration values on startup when the window opens. An operator wouldn't see these, but they get the trend chart set up properly. Now let's see what the trend display looks like now that we know how it's configured. Here we have the project running in offline simulation mode. The main trend display appears here, and the numeric objects show the values in each channel that are being sampled and drawn on the chart. That's all we have on the main trend display window. To change the appearance of the trend display during runtime, you would go to the settings window. Let's take a look. This settings window has a wide variety of controls that operators can use. It includes setWord and setBit objects to control things like the x-axis zoom measured in seconds. We can reset data sampling. We can reset all the configuration of the trend display chart here with the reset button. We can hold or pause the trend display itself with hold control. We can toggle each channel on and off with these buttons. We can back up our data sampling to USB or SD card. We can show or hide Y-scale axes, and we can choose which will be the main axis. So when we set it to channel 2 now resides just to the left of the trend display chart. And this is a mirror image of what we will see on the trend display based on how we've configured it. So channel 2 is the main axis here. Now let's reset this again. We also have a watch line, which on this chart you can click, you see the vertical line, and the corresponding values at that point in time are written into these registers. We'll take a look at the configuration of this later on. Now we have y-axis pan and y-axis zoom controls here as well. And you can see the dynamic limits low and high that are modified when you use the zoom or pan features. Now let's look at the settings window and the objects on it. First, a few objects that relate to our data sampling. We have restart data sampling, which is a toggle switch at local bit 0. And we have backup objects to write data to USB or SD card. Going back to the data sampling object that we set up, there is one thing that we need to look at here. This is the clear real-time data address. This is enabled and using local bit 0. So when we toggle this on, it will clear any currently held data that resides in memory in the HMI. Anything that's already been saved to ROM or to another media will not be deleted, but it will clear whatever sample data is in memory. Simultaneously, anything on a trend display chart will start over again when you clear this data. The backup objects are set to save historical data sampling to USB or to SD card in CSV format here. And these are set up from the Data History tab by choosing Backup per page. And these are all touch trigger based backup objects. Now for the other controls we have here. First we'll look at the Reset button. This is a combo button, and we use this to write the default values back into all of the configuration registers. So in order, what this will do: first it will set the x-axis time range back to 120 seconds. Then it will hide the y-axis scale information for all channels, set the channel minimum values back to 0, set the max back to 100. Next, the channel visibility is set on, and finally the main axis for y-scale information is set back to channel 1, although this will remain hidden. For our x-axis zoom feature here, we use two set word objects. If we take a look at the minus button here, this uses the style of press and hold increment, jog plus plus. This lets an operator zoom out on the trend display chart and show up to 5 minutes of data at a time. And the plus button here will use the press and hold decrement style instead, and go down to the low limit of 20, so you could show as little as 20 seconds worth of data on the chart at a time. The numeric display in between will just show the value currently in that register. Next, for the y-axis pan and zoom features. These work a little bit differently because we're dealing with two values, a low limit and a high limit. So if we want to pan up vertically or zoom in, we actually need to modify the values in both of these registers at the same time. And it may be easier to look at this in the simulation. For example, when we pan up, we notice the low and high limit are both incrementing in unison. Whereas when we zoom in, we see the low limit is increasing while the high limit is decreasing. So how do we achieve this with a single button? Well, in fact, what we have here are set word objects that are stacked on top of each other. So we made a copy of this window just to show you here. These are the two set word objects stacked on top of each other for the y-axis zoom in, and for pan up vertically, these are the two set word objects we have. So starting with the pan, at local word 100 is where we keep the low limit. So if we want to pan up, we would need to increment this, and we can go up to the high limit there. Since panning uses values moving in the same direction, we need to move the max value up here too at local word 102, so we do that in the same way. Contrast that with zooming, where we're moving the minimum value at local word 100 up here. At the same time, we will be decrementing the max value at local word 102 here with the second set word object. Next, we have hold control. This is simply a toggle switch looking at local bit 99, which is what we set up to be able to pause the chart in place. Next, we have toggle switches for channel visibility as well as for y-axis scale visibility. So again, these rely on a local word of your choosing, and you address the bit of that local word. So for channel visibility, we're looking at the bits of local word 200, and for y-axis scale visibility, we're looking at the bits of local word 500. Next, for the main axis, we simply use a set word object and write a value corresponding to the channel number into local word 30. That's what we chose for our main axis selection. And now we come to the watch line values. So this is particularly useful in combination with hold control. Let me show you. With the watch line enabled, as we've done for this smaller trend display chart on the settings window, an operator can click and you see the vertical line appear. The values are retained at the bottom there. Now, as the trend continues to be drawn and is moved, the values will change accordingly. So it's best to pause or hold the chart if you want to keep those watch line values stationary for some period of time. Maybe you want to capture these values, write them down, or take a screenshot, for example. So how do you set this up? In the trend display chart, for this you can simply set the hold control like we talked about, and then the watch line. You have to click enable here, and then you choose a starting register where these values will be written. So in fact, on this settings window, we set up numeric displays for local word 650 through local word 658, Again, we're dealing with 32-bit float values, so we need 2 registers for each of those channels. And that's how we can capture the values at a particular point in time using that watch line feature. Now, one alternative to a trend display with watch line values, especially if you want to be able to see values during particular slices in time, is to use a history data display. We've built one of these into this sample project as well. Let's take a look. On this window, we set up the history data display. Go to the data history tab and choose history data display to create one of these yourself. With this one, we've set the option to refresh data automatically. So what this means is every 10 seconds we'll see a new row of data representing the latest sampled values. And history control, this is an important selection to make here as well. Local word 40 is what we chose, and what this allows us to do is add an option list object. We do this from the object tab, select option list, and for ours we do a drop down list choosing dates of history data, and looking at that address we selected, this allows us to look at dates in the past as well. Now let's look in the simulation and you can see how it appears to an operator. You can see all of our data in tabular form here with the value at each channel, and this will automatically update every 10 seconds because we chose to refresh automatically. This option list allows us to look at previous dates, and this is a numeric object just to show the value in local word 40 at the moment, and that will change based on our date selection. Now, if you want to see values updating more frequently, that's not really the intention with the history data display, but you can set up a button like I've done here to refresh and see the newest row of sampled data. Normally you have to change windows in order to refresh the history data display. In fact, all this is a navigation button that takes us to a copy of this history data display window. Let's take a look. Change full screen window to window number 14, history data display copy. So we simply set up a copy of this window that is identical in order to allow you to refresh more frequently. Again, the idea is not to be able to see the latest data in real time. For that, you should probably use a trend display chart, but the history data display can be refreshed by changing the window in this fashion. That concludes our exploration of data sampling, real-time trend, and history data displays. To explore these features more yourself, download this sample project from our website, maplesystems.com. Look under Technical Support, Sample Projects. This project is called Trending, Sampling, and Data Backups. We thank you for choosing Maple Systems. Until next time.